All right. Good evening, guys. My name is Mr. Palacios, and we're going to talk about 8.2 relative frequency tables this week on statistics class. I'm going to try something new. I'm going to have a PowerPoint in the background. I'm going to switch in between screens. So hopefully this is a little better. Let me know if this is better for you guys, and I can try to do more of these. Or, like I said, the quality of the videos are going to get better as time goes by. In the meantime, what are relative frequency tables and what are you going to do with them? Um, the first thing is some vocabulary that you guys need to write down. Now, as far as this week is concerned, what I want you guys to do is as you're watching this video, I want you to take notes and you're going to upload those notes to me in order to get credit for this assignment to make sure that you get credit for watching the video. In addition to that, later on in the week, you're going to do the homework and practice, take a picture of that, upload that, and then that will be your work for the week. Um, so the reason why I want to see your guys' notes is I want to make sure that you guys are watching the video, paying attention, and going over key terms. Make sure you have them. So when it comes time to study for the test, you guys actually have a decent set of notes. Also, if I look at your notes and I see that you missed something that was key, I can point it out to you and I can help you out with that. So, with that said, let's move on. Joint relative frequency, the definition, and it's found by dividing the frequency that is not in the total row or total column by the grand total. Now, remember last week when we were talking about the grand total? I don't know if you can see the mouse, but right here, this is a two-way relative frequency table, and they're comparing clowns, acrobats, elephants, tamers with genders, boys and girls, right? And they're saying that, okay, this table tells me a couple different things, right? The meaning of a joint relative frequency, it tells you what portion of the total has both of the two specified characteristics. What they're saying here is joint relative frequency is saying that, okay, if there's three boys, right? Boys are going to go from left to right here. So all of these have to do with boys, right? This whole row here has to do with boys. And then this row going up and down that has to do with clowns is going here. What this is saying is they surveyed the class and they found that three boys said that they wanted to be clowns, right? Like if what was their favorite circus performer, and the boys said clowns. Three of them said they liked the clowns the most. So in order to find the joint relative frequency, what we need to do is we need to find the number of boys, three, and then we're going to divide them by the total number of people that they asked. Well, do you guys remember the grand total from last week? Remember here, the 2020, right? They asked a total of 20 students in the class, not boys, just students. That is the grand total. That's why it's 3 divided by 20 gives you 0.15, right? I have another example for this, right? Let me see if I can pull it up. There it goes. So as far as the joint relative frequency is concerned, we need to keep a couple things in mind here. This is a different example. This is about, we're going to be using this example quite a bit now. We're still bringing this up into gender by boys and girls, but we asked them this time how many people prefer basketball, football, soccer, right? These are our total numbers. So the total number of girls asked was 36, total number of boys asked was 44, and the total number of students, that includes boys and girls together, and that gives us the grand total. That's what GT stands for. It's always going to be here. So the grand total is circled. In order to find the relative frequency, we're going to end up dividing, but you're always going to end up dividing by the grand total, no matter what. So you're going to have fractions that you're going to turn into decimals, and decimals that you're going to turn into percents. That is the objective of this week. So if I were to ask you, okay, tell me what the joint relative frequency of girls who like basketball is, what would you do? Well, take a look at this. We're going to come back to it, right? Here's what I would do. The joint relative frequency of girls who like basketball is the number of girls who like basketball, right? Now let's go back. The number of girls who like basketball, right? Because remember, this is going down, then this is going left and right. So what that means is that the number we want is going to be 6 here. The number of girls who like basketball is 6. Okay, that's our numerator. That's where we got this. That's where we get this from right here. So we get 6 divided by the grand total. Remember, when we go back here, we're saying the grand total was 80, right? So that's where we got 80 from. So we have a fraction. We're going to have 6 divided by 80. Now, when you put this into your calculator, make sure you put the 6 first. Okay, I know this is going to be weird. You're going to end up with a decimal, and that's exactly what you want. Now, if you notice here, I have F, D, and P. That just means fraction, decimal, and percent. So this is my fraction, 6 over 80. When I put this into a calculator, I get this number 0.075. That is my decimal, right? You will have to put decimals or you will have to put percents on your homework and practice. It depends on what the problem is asking. If they're asking for the decimal, they just want this, and this is your answer. You'd be done. If they're asking for the percent, however, you need to convert it. So how do we go from here to here, right? Well, whenever we have a decimal, in order for us to convert the decimal into a percent, we need to multiply this by 100, right? So if you put 0.075 into the calculator and you multiply that by 100, you're going to get a percent. You get 7.5%, right? Now, the calculator will just say 7.5, but you need to know that that's actually percent. Um, there is an easier way. I don't know if you guys noticed. Let me go ahead and erase this part. I don't know if you guys noticed there, but I had 2 little lines there. There is a shortcut, and I do encourage you to use a shortcut, but I needed to explain to you what the shortcut was. You still need to multiply by 100. However, the shortcut to that is whenever you multiply any decimal by 100, what you're actually doing is you're moving the decimal over 2 places to the right. What that means is this decimal goes from between these 2 zeros to between the 0 and the 7 to between the 7 and the 5. And then it lands there 2 spaces to the right, and it converts it into a percent every single time. That is a shortcut that you would have learned probably around a lot of years ago. I don't know. I don't remember what grade exactly they teach you this, but for the sake of this assignment, it's going to help out a lot. So I would encourage you to do that. If you want to multiply by the 100 just because you're like, you don't want to forget, that's fine too. But in this case, the answer to what is the joint relative frequency of girls like basketball? It's 7.5%. Right? Oh, by the way, side note, it's okay for you to have a decimal in your percent. We try not to, but you might see that throughout this assignment, so that it's okay for you to have that. We'll talk about that when we talk about place values later on. Okay, so what about marginal relative frequency? Okay, let's get the definition for that first, right? In your notes, make sure to write marginal relative frequency. It's found by dividing the row total or row column. If you're wondering what that means, by the row, like for example, let's look at this table down here. Male, row means that we're going from left to right. So for male, we have sports utility vehicle, 21, sports cars, 39, total 60, right? Our marginal frequency means we're gonna divide our row total. That means the total number of males, well, there's 60 males, right? If you notice, it says marginal frequency on the side, and it has 60 and 180, right? If I move this over, if I leave it alone, there you go. The totals down here for sports utility vehicles is 156 SUVs and 84 sports cars total down there. Those are going to be their numerators, right? Your denominator is still going to be your grand total. That means it's 240, right? So if I wanted to know what the marginal relative frequency was for, let's see, males, right, in this study, it would be 60 divided by 240. That's what I would do. Let's go back to the example and see what example we came up with. In order to find out the marginal relative frequency, what is that going to tell us? Well, it's going to tell us the percent of students who prefer basketball over all the other sports. Now, in case you're wondering where I'm getting this information from, again, this is based off of this table, right? So if we go here, the percent of students who prefer basketball over the other sports, we want to know the total number of students who prefer basketball. So let's go back to the table. Total number of students who prefer basketball. If you notice here, I have it right here. Basketball down here. We wanted the total, so we're not going to pick girls or boys. If we're doing the marginal relative, we're dealing with totals. So that's 20 is our numerator, and we're going to divide it by, what are we going to divide by again? The grand total. If you didn't say grand total, you should have. Remember, we're dividing everything by the grand total. Joint and marginal relative frequencies, you're going to have to divide by the grand total. Condition was going to be something else. Okay, so here we have 20, and it'll be divided by our grand total, which is 80. We put that into a calculator. Again, we're always going to get a decimal, 0.25. Again, I'm going to use that trick that I told you earlier. I'm going to move this decimal over 2 places to the left, and I end up with 25. That's my percent, which is 25%. The answer to my question of what percent of students who prefer basketball over other sports, 25% of students prefer basketball over all the other sports, according to this, according to what we learned. That is the marginal relative frequency, okay? Again, it's just, can you remember what the fraction is, all right? So next is something called conditional relative frequency. I'm going to go ahead and show you the definition for it, a little cleaner because my handwriting is terrible. The definition is found by dividing the frequency that is not in the total row or column by the total row or column. So if you notice here, same chart as the one from before. However, the conditional relative frequencies, our numerator for this is going to be one of these guys. You see in the blue, right? You see how, like, for example, we have male who prefer sports, who prefer SUVs, is 21. We have females who prefer SUVs, 135. We have males who prefer sports cars, is 39. And we have females who prefer sports cars, which is 45. Those are our original numbers, right? And then what we're going to do is we're going to take those numbers, that's our numerator for our conditional relative frequency. This time, however, is conditional relative frequency is the only time we're not going to divide by the grand total. We are, however, going to divide by the totals of the row and the column. So if I wanted to find the conditional relative frequency of males, 21 males, right, and 39 males, who the conditional relative frequency of males who prefer SUVs, I would take 21 because remember, the one I'm looking for is SUVs and males, so that's 21. And I would divide that by the total number of males that I asked. I'm not including the females in this because conditional relative frequency only focuses on one of them, either male or female, either SUVs or sports cars, right? So the total number of males that they asked was 60. So I'm going to, if I want to find the row relative frequencies, I divide the male row by 60. That means 21 divided by 60 is 35. The conditional relative frequency is 0.035. If I wanted to find out what the conditional relative frequency of males who prefer sports car, it would be 39 over 60, that's 65%, right? So that gives us a different piece of information. Why don't we compare this to what we've been looking at? So let's take a look at here. The conditional, if I wanted to find out what the conditional relative frequency was for the percent of girls who like basketball out of the total percent of students who like basketball. Now, that's a little confusing, but just bear with me here. The number of girls who like basketball is going to be my numerator. And I'm going to divide that by the total number of students who prefer basketball in general. I end up with 6 out of 20. That can be hard to picture. So let's go back to the chart here, right? So the number of girls who prefer basketball, we've established as 6, right, from the previous problem, right? So I'm going to go ahead and double circle this. That's 6. And I'm going to divide the number of girls who like basketball by the total number of students who prefer basketball. There's a small difference there, but it's an important difference that you're going to have to make. 6 divided by 20 is going to give us a complete difference. This only tells us out of all the students who prefer who have basketball as their preferred sport, as their favorite sport, how many of those students are girls? What percent of those students are going to be girls, right? Well, let's find out. Okay, so let's go back. Now over here, let's see. Oh, there it goes. 6 divided by 20 is going to equal to 0.3, and then that's going to equal to 30%, right? So over here, we have frequency is equal to, we have fractions is equal to decimal, which is equal to percent. This is my fraction. This is my decimal, which is 0.3. Now here we have an interesting situation. Be very careful here because The shortcut says we're going to move the decimal over 2 spaces to the right, but there's no space here, right? So when I move it over 2 spaces to the right, it goes from this after the 3, it goes to the next one. But there's a space there, which means we're just going to add a 0 there. It's not 3%, it's going to be 30%. Just be very careful about that because it will give you the wrong answer if you're not careful, right? Okay, so let's do an example problem over here. For part B, where it says Millie performed a survey of students in the lunch line and recorded which type of fruit each student selected along with their gender of each student. The two-way frequency table data is shown below. Objective, find the relative frequencies and place them in the correct box. So here, what I want you guys to do, pause the video, right? And I want you to see if you guys can figure out what the joint relative frequencies are going to be like. Right here, I have Apple and it's 17.4%, right? So I'm going to give you the directions on how to find it, and I want you to fill out these boxes. Check your answers in the next slide, right? And make sure to have this down in your notes. I want to see that you guys figure this out and how you figure it out. Show your work, right? I want to see the fractions, I want to see the decimals, and I want to see the percents. This is how you earn your points. Okay, so here, how do I find the relative frequencies? Find the box that crosses both bananas and girls. So here, I have apples, I have boys, and I have totals. That's already filled out for me. That's already figured out. I'm going to start where it says banana and girls, right? There's a blank box. On the box above where it says the number of girls who prefer bananas is 10, and we have a grand total of 90, right? So I'm going to, so on the direction says you will see the value of 10, right? So that's 10. And I'm going to divide that because I want the joint relative frequency. So I'm going to take 10, and I'm going to divide it by the grand total, which is 92, right? And do you guys see 92? It's a grand total down there. 10 divided by 92 is 0.1086, which is 10.86%. 10.86% are girls who selected a banana, right? So on the bottom here, where it says joint frequencies, and there's like a blank box, you would just write down like the sentence on your notes. 10.86% are girls. If you want to write, you see how I wrote like 10 divided by 92 is equal to 0.1086 equal to 10.86. I want you guys to show that for all of them. Fill out this table, all right? So pause the video if you need to. Fill them out, take your time. Unpause the video when you're done and compare it. If you get something wrong, mark it, right? But don't erase it. If you make an error, I want to see where the errors are, right? You're not going to lose points, but it helps me understand how much you understand and what you were thinking. So please do that. Don't erase your mistakes. Now, for the marginal frequencies, right? I'm assuming you paused the video, right? And you should have gotten it. In red is the answers for the previous problem, right? This is what you should have gotten. And as far as the marginal frequencies are concerned, we're going to solve them the same way. However, the marginal relative frequency selected for an apple, I'm going to show you what it is because a lot of people are confused about that. So on the side here, I actually have the answers. Okay, what if I were to ask you, instead of writing the joint relative frequencies, I ask you, what are the marginal relative frequencies? Well, in order for me to find the marginal relative frequency of the total number of people who prefer apples as their favorite fruit, I would go to my total, right? Where it says apple and totals at the first graph, right? Do you guys see that? Where it says apple, and on the bottom it says 41. There's a total of 41 people who prefer apples as their favorite fruit, right? Now 41 divided by 92 is 0.466. All right, do you see that right there? And then that, I move the decimal over 2 places to the right, and that equals 44.6. So on the box down there where it says marginal relative frequency, selected an apple, 44.6% selected apple, 25% selected a banana, 28% selected an orange, 43.4% are girls, 56.5% are boys. On your notes, I want you to write down how I figured out what the marginal frequency is, what I divided by what. What am I supposed to divide by what? Look back in your notes. I want to see if you understand what I did and why I did it. Give me an explanation, right? I need to be able to read that. Okay, next. If you're not done with that, pause it. Then there's going to be one more. So, okay. Last one, conditional relative frequency. There's a lot here, but just know that we're doing part B, right? Where it says use the data from example 1B, find the conditional relative frequency that a student in Millie's survey chose in orange, given that the student is a boy. Now, part A gives you an example of what you should do, right? So go ahead and look that over if you're still confused. But for part B, number of blank who chose an orange over the number of blank is equal to blank over blank is equal to approximately 2.69, approximately what percent? I have that on here on the side, right? So the total number of what goes in the blank is boys who chose an orange, right? If I want to find out the conditional relative frequency of students who chose oranges and that student has to be a boy, then I'm looking for the total number of boys who chose an orange over the total number of boys in general, right? The total number of boys that there are. So I have 14, right? Which is going to be divided by 28. How do I know that? Well, right here where it says boys, right? Sorry. Oops. Oh, sorry. Okay. I got confused for a second there. Over here, we're referring to this one, right? So boys, if you see that we have boys who prefer orange, there's 14 boys who prefer an orange, and there's a total of 28 boys who prefer oranges, right? So lucky for us, that means that there's 14, which is the total number of boys who chose an orange as their favorite fruit, divided by the total number um, of people who chose oranges, right? So that's 28. So 14 divided by 28 is going to be 0.5. And again, we move it over 2 spaces to the right and we add a 0 at 50%. So our answer is 50%. What I want you guys to do right now on there, you see where it says the your turn problem, where it says 6 and 7? On your notes, go ahead and answer those 2 questions and only those 2. What is the conditional relative frequency of students who likes to lift weights, given the student does not like uh, um, aerobics? Find the conditional relative frequency of those. Um, let's see. Oh, you know what? I don't think I included the chart for this one. I don't think you guys can do this. Using data from 4 or 5. Yeah, don't worry about that. Never mind. Sorry about that. Don't do 6 and 7 because you actually can't. I cut that out from the previous video. So don't worry about that. Make sure you guys write an explanation for what is conditional frequency. Explain what I did here in your own words. Again, I want to see your own words, explanation for what it is. I don't want to just see a repeat of what I did, of what I told you. Really explain in your own words, what are you doing, what makes sense to you. If you're still confused, write why you're confused, what is confusing you. Is it the fractions, is it the decimal, is it percent, be as specific as possible. Another thing is join me for my Zoom at 10 to 11 a.m. The link is in the Google Classroom. If you guys have any questions, join the Zoom so I know that you guys are engaged with the class. It is mandatory for you guys to join a couple of Zooms throughout, at least one Zoom throughout the week to check in to see what you're doing, right? So check in if the 10 to 11 doesn't work for you, email me so that we can work out a different time where we can meet through Zoom. All right, guys, good luck. And that's it for today.